Animatronics is a multidisciplinary field which integrates anatomy, robots, mechatronics, and puppetry, resulting in lifelike animation. Animatronic figures are often powered by pneumatics, hydraulics, and or by electrical means, and can be implemented using both computer control and human control, including teleoperation. Motion actuators are often used to imitate muscle movements and create realistic motions in limbs. Figures are covered with body shells and flexible skins made of hard and soft plastic materials and finished with details like colors, hair, and feathers and other components to make the figure more lifelike. Animatronics is the use of cable-pulled devices or motors to animate a replica of a human or an animal, or bring lifelike characteristics to an otherwise inanimate object. Animatronics were first introduced by Disney in 1962 for the film Mary Poppins, released in 1964, which featured an animatronic bird. This was controlled fully by bicycle cables. Modern animatronics tend to use robotics and have found widespread applications in movie special effects and theme parks, and have, since their inception, been primarily used as a spectacle of amusement. A robot designed to be a convincing imitation of a human is more specifically labeled as an android. Animatronics and artificial intelligence. The fusion of animatronics with artificial intelligence results in androids, as is usually known, robots that imitate human behavior. We have a technique capable of providing the appearance and behavior of living beings to machines. We are humanizing robots. But it's not only the movements that look very real, but also, it seems real thanks to the synthetic skin they have used and makeup. The Disney company is about to use animatronics and artificial intelligence to simulate one of their characters in real life, Pascal, one of the characters in the movie Tangled. On the other hand, Dubai is already using police robots created by PAL Robotics. Design. An animatronics character is built around an internal supporting frame, usually made of steel. Attached to these bones are the muscles, which can be manufactured using elastic netting composed of styrene beads. The frame provides the support for the electronics and mechanical components, as well as providing the shape for the outer skin. The skin of the figure is most often made of foam rubber, silicone, or urethane poured into molds and allowed to cure. To provide further strength, a piece of fabric is cut to size and embedded in the foam rubber after it is poured into the mold. Once the mold has fully cured, each piece is separated and attached to the exterior of the figure, providing the appearance and texture similar to that of skin. Structure. An animatronics character is typically designed to be as realistic as possible and thus, is built similarly to how it would be in real life. The framework of the figure is like the skeleton. Joints, motors, and actuators act as the muscles. Connecting all the electrical components together are wires, such as the nervous system of a real animal or person. Frame or skeleton. Steel, aluminum, plastic, and wood are all commonly used in building animatronics, but each has its best purpose. The relative strength, as well as the weight of the material itself, should be considered when determining the most appropriate material to use. The cost of the material may also be a concern. Exterior or skin. Several materials are commonly used in the fabrication of an animatronics figure's exterior. Dependent on the particular circumstances, the best material will be used to produce the most lifelike form. For example, eyes and teeth are commonly made completely out of acrylic. Latex. White latex is commonly used as a general material because it has a high level of elasticity. It is also pre-vulcanized, making it easy and fast to apply. Latex is produced in several grades. Grade 74 is a popular form of latex that dries rapidly and can be applied very thick, making it ideal for developing molds. Foam latex is a lightweight, soft form of latex which is used in masks and facial prosthetics to change a person's outward appearance, and in animatronics to create a realistic skin. The Wizard of Oz was one of the first films to make extensive use of foam latex prosthetics in the 1930s. Silicone. Disney has a research team devoted to improving and developing better methods of creating more lifelike animatronics exteriors with silicone. RTV silicone, Room temperature vulcanization silicone is used primarily as a molding material as it is very easy to use but is relatively expensive. Few other materials stick to it, making molds easy to separate. Bubbles are removed from silicone by pouring the liquid material in a thin stream or processing in a vacuum chamber prior to use. Fumed silica is used as a bulking agent for thicker coatings of the material. Polyurethane. Polyurethane rubber is a more cost-effective material to use in place of silicone. Polyurethane comes in various levels of hardness which are measured on the Shore scale. Rigid polyurethane foam is used in prototyping because it can be milled and shaped in high density. Flexible polyurethane foam is often used in the actual building of the final animatronic figure because it is flexible and bonds well with latex. Plaster. As a commonplace construction and home decorating material, plaster is widely available. Its rigidity limits its use in molds, and plaster molds are unsuitable when undercuts are present. This may make plaster far more difficult to use than softer materials like latex or silicone. Movement. Pneumatic actuators can be used for small animatronics but are not powerful enough for large designs and must be supplemented with hydraulics. To create more realistic movement in large figures, an analog system is generally used to give the figures a full range of fluid motion rather than simple two-position movements. Emotion modeling. Mimicking the often subtle displays of humans and other living creatures, and the associated movement is a challenging task when developing animatronics. One of the most common emotional models is the Facial Action Coding System, FACS, developed by Ekman and Friesen. FACS defines that through facial expression, humans can recognize 6 basic emotions: anger, disgust, fear, joy, sadness, and surprise. Another theory is that of Ortony, Clore, and Collins, or the OCC model, which defines 22 different emotional categories. Thanks for watch. Please subscribe, share, comment.